Welcome students to the first module of chapter number 12, Carbon, an important element. In this module, we will learn all the basic information about this very important element carbon and its occurrence. Then we will learn the concept of allotropy and various allotropes of carbon. Under that, we will study two crystalline allotropes of carbon, that is diamond and graphite, in detail. You have learned that carbon is a non-metallic element. You have also learned about its occurrence in nature in the form of some compounds. Let us do one activity. Take some milk in an evaporating dish. Heat the evaporating dish on the burner. What remains behind at the bottom of the dish on completing evaporation of the milk? Now take a piece of chapati or any food, plastic and dried leaves, and also heat each of these substances and observe the changes taking place in the substances. What does the black substance remaining after burning each of these substances indicates? This black color substance remain behind indicates the presence of carbon in that particular substance. The element carbon is available abundantly in the nature. We can do one activity. We can make a list of all the substances or the objects that you use in daily life from morning till night. The list will contain foodstuff, clothes, medicines, fuels, wooden object, etc. And carbon is the common and important constituent of all these substances. We have studied compounds in previous standards. Some compounds that we obtain from minerals are called as inorganic compounds. For example, salt, water, oxygen, etc. And the compounds that we obtain from plants and animals directly or indirectly are called as organic compounds. All the organic compounds contains carbon. Carbon is the main element even in cellular DNA and RNA that transfer hereditary characteristics from one generation to the next. Let us know some basic information about the very important element carbon. Symbol of carbon is C. Atomic number of carbon is 6. Atomic mass of carbon is 12. Its electron configuration is 2 4 and its valency is 4. It is a non-metallic element. The name carbon is derived from the Latin word carbo, which means coal. Carbon is found in nature in free state as well as in combined state. Carbon in the free state is found as diamond and graphite, and in the combined state it is found as carbon dioxide and in the form of carbonates such as calcium carbonate, marble, etc. Also, carbon is there in the fossil fuels, for example, coal, petroleum, natural gas, etc. All the carbonaceous nutrients like carbohydrates, proteins, and fats contains carbon. Natural fibers like cotton, wool, and silk also contains carbon. In the earth crust, carbon is present to the extent of approximately 0.27% in the form of carbonates, coal, and petroleum. In atmosphere, the proportion of carbon in the form of carbon dioxide is approximately 0.03%. Some elements occur in nature in more than one form. Some elements exhibits same chemical properties but different physical properties, and these substances are called as allotropes, and this property of elements is called as allotropy. Like carbon, sulfur and phosphorus also exhibits allotropy. In this lesson, we are going to discuss allotropes of carbon in detail. Allotropes of carbon are majorly divided into two types: crystalline allotropes of carbon and non-crystalline, or we can also say amorphous allotropes of carbon. Crystalline allotropes of carbon has a regular and definite arrangement of atoms in it. Also, they have high melting and boiling points. A crystalline form of carbon has a definite geometrical shape, sharp edges, and plane surfaces. Carbon has three crystalline allotropes, namely diamond, graphite, and fullerene. So let us know about all these crystalline allotropes in detail. Let us know more about the crystalline allotrope of carbon, diamond. Diamonds are found in India, mainly in Govalkonda, Karnataka, and Panna, Madhya Pradesh. Diamonds are also found in South Africa, Brazil, Belgium, Russia, and America. In diamond, every carbon atom is bonded to neighboring atoms by covalent bond. Therefore, diamond has a tetragonal three-dimensional structure which makes it very hard substance. Let us discuss some important properties of diamond. Brilliant and pure diamond is the hardest natural substance. The density of diamond is 3.5 gram per centimeter cube. The diamond's melting point is 3500 degrees Celsius. Diamond does not dissolve in any of the solvent. Acids and bases have no effect on diamond. Diamond is a bad conductor of electricity as it does not have free electrons available for conduction. When diamond is heated at 800 degrees Celsius in the presence of oxygen, carbon dioxide is given away. In this process, no other product besides CO2 is formed. Let us discuss various uses of diamond. Diamonds are used in glass cutting and rock drilling machines. Diamonds, being the hard substance, can precisely and accurately cut the glass in any desired shape or form. Small particles of diamond are embedded in saw blades, drill bits, and grinding wheels for the purpose of cutting, drilling, or grinding hard materials. Diamonds are used in ornaments because when it cut by experts, it will sparkle and reflect light in an attractive way. Diamond knives are used in the eye surgeries because these knives have accurate cutting edges. Diamond knives are used in eye surgeries to cut the cornea in order to treat clouding of the lens or surrounding tissues. Diamond dust is also used as an industrial polish. It can be used to polish other surfaces and a wide variety of materials, including diamond itself, to a nice shine. Diamond is also used to make windows, giving protection from radiation in space and in artificial satellites. Let us know about next important crystalline allotrope of carbon, that is graphite. Graphite is found in the natural state in Russia, New Zealand, America and India. The lead used in pencil is made by mixing graphite with clay. Every carbon atom in graphite is bonded to three other carbon atoms in such a way that hexagonal layered structure is formed. A graphite crystal is made up of many sheets or layers of carbon atoms. These layers slip over each other on applying pressure. One layer of graphite is called as graphene. Let us study various properties of graphite. In graphite, every carbon atom is bonded to other three carbon atoms in such a way that hexagonal layered structure is formed. Inside each layer, free electrons are continuously moving within the entire hexagonal layer. And that is why graphite is a good conductor of electricity. Let us do one activity. Sharpen a lead pencil from both its ends. Now connect both the sharpened ends using electric wires, one end to a cell or the battery and the other end to a small bulb which is in turn is connected to the other end of the battery. Start the electric current in the circuit and observe. You will see that the electric bulb in the circuit glows. And this experiment shows that graphite, which is present in the pencil lead, is a good conductor of electricity. Let us see some more properties of graphite. Graphite found in nature is black, soft, brittle, and slippery in nature. The density of graphite is 1.9 to 2.3 grams per centimeter cube. Graphite does not dissolve in most of the solvents. Let us discuss various uses of graphite. Graphite is used as lubricant. The layers in graphite can slide over each other because the forces between them are weak. This makes graphite slippery, so it is useful as a lubricant. Graphite bonds are formed of only 3 out of the 4 valence electrons of carbon, leaving the fourth electron to move freely. Hence, it is good conductor of electricity and it is used in carbon electrodes. Graphite molecules are flat groups of carbon atoms that are stacked in layers. The layers slide against each other and allow the lead to slide off the pencil point and onto the paper. When you erase with a rubber eraser, the graphite in the lead sticks to the rubber better than it does to the paper. Hence, it is also used in pencils as a lead. Graphite is also used in paints and polishes and also in various coatings which can reduce the hot spots and therefore increase the overall thermal stability of a coating in an environment where radiation heat transfer is an issue. Graphite is also used in arc lamps. An arc lamp produces light by the sparkling and electrical arc of an high current between two conducting electrodes, usually carbon rods.